It's recording. Let's share screen. Oops. Yo, forecasting. Uh, Forecasting is very easy. So basically, the most time-consuming thing is time series transformations. But when you have finished transformations, when it's a good, simple data table with index, with keys, with data columns, then it's very fast. So let's start. So first idea that that is good to mention, that always use simple models for comparison. Always use simple models for comparison, because you may estimate your model, you may do some time series decomposition, you may do that or this, and basically you spend a lot of time, and you always should compare with something trivial. Two trivial models, two, maybe three trivial models. Three trivial models are, first model is next, so it's called naive model. First one is naive. Then the next one step ahead forecast, yt plus 1 forecast is just yt. So what is the weather tomorrow? I guess like today. So it's a naive model, but if naive model gives you mean absolute error of 5, and your model with neural networks, model averaging and so on gives you 5.2, maybe not, it's not worth the effort. I don't know, but my idea is just always compare your model with a simple model. What are two others trivial models? Seasonal naive model is like the next months. So imagine we speak about monthly data. So the next months will be like 11 months before, so the corresponding months of the previous year will be like 11 months before. Seasonal naive. Next month, next February, will be like previous year February. And the third simple model is mean model. That means the hat y t plus 1, the prediction for the next month, is average of all past observations. So these three trivial models, they may be comparable with a model for which you have dedicated 2 hours of modeling. So don't forget these naive models. Or even your model is better than these naive models. Maybe you can just average naive model with your model and get even better forecasts. So sometimes not only for comparison, but this sometimes. So first reason to use simple models is to understand whether effort is worth time, because when you model time series, you use your time. So maybe if trivial model is comparable with a complex model, maybe trivial is better. And the second use of trivial models is model averaging. Model averaging. Sometimes it happens that sometimes something like 0.5 times seasonal naive plus 0.5 times complex model is better than complex model. So sometimes you can just average forecasts from simple model with forecasts from complex model to get a better model. So there are at least two reasons to use simple models: for comparison and for model averaging. Sometimes you can ameliorate your complex model by just using a simple one. Okay, so let's once again start with our, not our, but Australian data set about production. Let's use beer production and let's use some simple models. We will take Australian production. We will use pipe syntax. And then we just say that we will model. And then we just write models. So let's imagine naive model will be just naive model for beer. What else? We will have a seasonal naive model is seasonal naive model for beer, and mean model is just mean model for beer. What else? What are other some simple slats? Drift. So some very simple models like random walk with drift. So I may add here random walk with drift. Plus hat drift. So random walk with drift just says every next observation is higher than the previous one by some constant amount that is called drift. Yes, it's very simple model. These four models are, that's four. Trivial, they're very simple. They have no parameters at all, no parameters at all, no parameters at all, or you may see that it has, so sometimes you may say that it has, if you'd like to speak about confidence interval, so you may have one parameter there, one parameter sigma there, two parameters there, mu and sigma, and two parameters there, drift and sigma. So it depends on whether you are speaking about confidence interval or not. Okay, I think that's all. So we have estimated 4 trivial models. Let's for the moment, it's just so we just have information that we have naive model, seasonal naive model, mean model, and random walk with drift model. Let's make, so what is the procedure? So we estimate models, we can forecast using them. Basically, that's all. We can evaluate forecast quality, but basically, what is the use of all models? To forecast something. Let's create forecasts. Forecasts. We just forecast models, and we say that, let's say, for 2 years. We have done forecasts. So these are our forecasts. What do we have here? We have a model. Because I have requested 2 years. 2 years means for us 8 observations, because we have quarterly data. And so each year of forecasts is gives us 4 observations, and 2 years of forecasts gives us 8 observations. So for naive model, I have for naive model, I have 8 forecasts, and each forecast I have 2 types of forecasts. I have point forecasts, and I have distributional forecasts. So in naive model, so the point forecast is 3.74, and distributional forecasts is like normal distribution with mean 374 and estimated variance. If you'd like to get prediction intervals, then so here you have point forecasts and distributions, distributional forecasts. If you'd like to have predictive intervals, and we can get something like forecasts. I think it will be high low. Level is let's say 90%. Yeah, we have we have added to distributional forecasts and point forecasts. We have predictive intervals. We may draw all of this. So basically, that's the main use of all models in time series. We have models, we have forecasts. Basically, that's all. So we have done a lot of forecasts with a lot of models in just 2 lines. With 1 line, we have estimated 4 models. With 1 line, we have done forecast, and now we just look at them. Everything is finished. Basically, the most time-consuming thing is data transformation. Let me look at forecast on autoplot. Forecasts. Yeah, I have so I have a lot of maybe let me use some. Let me select. So first let me add original data set as production. Let me add. Yeah, I think that's much better. And I have 4 models, and we see that the seasonal naive model is will be a good candidate to compete with more complex models. So in this case, when you have seasonal data, do not forget about the seasonal naive models. Sorry, here the specification is written for monthly data, and on my plot I have quarterly data, but I think you will understand that in this case it will be t-3 is the forecast for t+1. I think that's okay. It will not confuse you the difference between monthly and quarterly data. Okay, that's we have done forecasting with simple models. Now let's do some. We have studied ETS model, yeah. Let's do some ETS models. As far as I remember, last week we have discussed ETS models. Yeah, do you remember what is the ETS model?
Yes. Yes.
Okay, so that's the same thing. We just take models.
And what kind of ETS model will we look at? AAA?
Sorry.
I'd say, what kind of ETS model are we looking at? triple A?
We can look at any one. We can even ask for automatic estimation. So let's models. So now we just do the same thing, but we will use aus production model, and now we will add ETS AAA, ETS. So I say the dependent, the modelet variable is beer. I don't know. I think error is A. Trend is A, and the season is A. We have discussed, I think, ETS model. We will add trivial model that will be seasonal naive for beer. Yeah. Now let's do forecasts. Forecast models, and let's say for 1 year we can look at the forecasts. So now we have all forecasts with confidence intervals. So now we have just 4 forecasts for each model, because I have selected 1 year ahead forecast, so it means 4 quarters. And I have forecast for 2 models, for ETS and with a trivial model. Okay, so basically complex model, you just specify model. ETS, you have a RIMA, you can do ETS with not with additive, but with multiplicative error. You can do automatic ETS. I think if I will do something like, so if I just will try auto what I can do automatic ETS, like automatic ETS. I just need something like, I just remove the specification, yeah, and that will give me, let's look at the models. So we have ETS AAA, and it says that automatically ETS MAM was selected. So automatically the error is selected to be multiplicative, trend is selected to be additive, and seasonal effects are selected to be multiplicative. If we use automatic selection, if you'd like to discover equations, so you need to do some models like so ETS AAA. You need first model, yeah, in the list. And you have a lot of information that you have estimated alpha, beta, gamma. We have discussed the meaning of these parameters in a model. So if you'd like to extract all the information to write equations, yeah, you can. What else do we need? And maybe once again, I should point you to the forecasting principles and practice if you'd like to learn more about all these ETS models. So then just where it is, where it is, you have this text, and there is a chapter dedicated to ETS models. So just read it to better understand what's the ETS model. What we can do more? We can do automatic transformations. So variable transformations. Yeah, maybe let's do, we have already estimated a lot of models, naive models, ETS models. We need to compare models. So let's compare models. Model comparison. Using train test split. Train test split. So what I will do, I will split my data set into two splits. On the first one, I will estimate models. Then I will predict my models, trivial models, automatically estimated ETS, ETS AAA. I will make predictions for my test data set, and then I will compare predictions. Okay? Yeah.
Yep.
Could you repeat?
Maybe.
Yeah, that's clear.
Could you repeat,
Maybe
please?
even maybe we can compare. That's a bad type of comparison, but we may do model comparison on training sample. On training sample. So what ratio will you use for the splitting? We have no strict rules. I think let's use 2 years. But there are no clear answer for your question. So we have model comparison on training sample that just, we can say, accuracy of models. This will be the model comparison on training sample. So on training sample, let's look at mean absolute error. For ETS AAA, it is 11.9, and for trivial model, it's 15. But yeah, trivial is not so good as ETS on training sample. But let's look what happens on the test sample. Okay, so model comparison on training sample is just accuracy models, and for model comparison using train test split, we need to split before model estimation. So I will let's look at the tail of my data set, aus production. Let's say tail 8 observations. So I will filter these observations. So aus train will be filter aus production quarter is less than 2008 Q2. This is my training set. What else? What else? Maybe Q.
Isn't this format
Okay.
your month?
Sorry. Sorry. Could you tell your question once again?
Isn't this format your month or your quarter of YMD?
It doesn't care. It will take care. So I will just write what is the starting of the second quarter. The first quarter is first 3 months. The second quarter is up to let's check whether it will work. But it worked. Yeah, it worked with. So it worked. It was just a warning. Q2. Let's check tail aus train. It's just a warning. But I think the conversion is done automatically. Yeah, it worked. It has worked. it was just a warning that there is a difference between data types, but that's okay. Aus test filter aus production quarter is greater or equal to year quarter of Q3. Let's work aus test. Yeah, we have exactly 8 observations. Okay. Now we have 2 splits, aus train and aus test. Yeah, we have 2 splits. We can estimate our models on aus train model, and we need what we need. We need seasonal naive. My idea is always compare with a simple model. Seasonal naive beer. What else? We may say ETS AAA. It will be ETS. I will just copy my code for ETS AAA model. Pum, 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 pum. Okay, what else do we have? I think we will add ETS auto. It will be just ETS here, beer. And I think that that's enough, yeah. We have 3 models, 3 competing models. So now we have estimated 3 competing models for our data set. Naive model, seasonal naive, more exactly, ETS with additive error, with additive trend, with additive seasonal effects, and automatic ETS. And it happens that automatic selection procedure has chosen ETS with multiplicative error, with additive trend, and with multiplicative seasonal effects. Okay, any questions up to that?
Probably not.
Okay, so now we will do forecasts and we will calculate accuracy. But as we have our test data set, so we can evaluate the quality of forecasts on the test data set. So that will be a honest forecast quality evaluation. Okay, so now let's make forecasts. We just forecast model using all the models for 2 years. Yeah, we have forecasts. And so these are the forecasts. And for every model, we have 3 models. For every model, we have 8 forecasts for 2 years because we are working with quarterly data. And now we just calculate accuracy, I think. Accuracy, what do we need? Accuracy of forecasts. But we supply our test sample, I think. Yeah. I don't know why mean average standard error is mean average symmetric error. Why it's not? Why I don't know for the moment why I have not a number there. So I will think a little bit why mean absolute symmetric error is 0. Right. So okay. Anyway, let's focus on mean absolute error for the moment. So we see that the best one is automatically selected ETS because it has the lowest mean absolute error. Our ETS with all additive effects is a little bit worse. And seasonal naive is the worst model, but the difference is not so high. It's roughly 20%. So it's not a big difference. It's not twice. Yeah, it's not. Yeah, mean absolute error is bigger, but not so much. Yeah, it's bigger. Yeah, okay, but not so much. Okay, but why it's 0? I don't know. Maybe. No, 1, 2, 3. No, I will think. I don't understand for the moment why this is 0 is not. Okay, I will think a little bit about this. So basically, we have compared forecasts of these 3 models. What we can do more? What are some subtleties? Automatic. We may do automatic variable transformations. What do I mean by automatic variable transformations? For example, I may take logarithm of my variable of my beer production, then model the logarithm by ETS, and then go back to original variable. So I may do something like from yt go to zt equal to logarithm of yt, model logarithm of yt. I even will not introduce as ETS, and then make predictions, and then go back from forecast of logarithm of yt to forecast of yt. That's a good strategy. Sometimes additive models are estimated on logarithm of original data. Then after the forecasting, we go back to original variables. And these transformations are standard, and they are done automatically. I will just write log, and everything will be done automatically. So I have 4 steps to do. So I have first one, go from yt to log yt, then model log yt as it is, then make predictions, then take predictions and go back. It's done with, I don't know, 5 symbols, not one line, 5 symbols for this strategy. So I will just like op. I will add one more model. I will create ETS AAA for logarithm. And I will basically copy my code. But I will write here that I model not beer, but log beer. And that's all. I have everything. So I go here, models. So I make forecasts, and I test accuracy. And my ETS model, that is ETS AAA, but with logarithm and going back to original time series, this model is, I think, the best by root mean squared error, and on par with automatic ETS using mean absolute error. Okay? Any questions?
Sorry, and what is MPE? What is the error?
MP, honestly speaking, so I think this is mean absolute error. This is mean percentage error. So let's just, so you have help and you have books. So I don't remember all the name, but I think if we model two measures a list of point accuracy measures, and we have MPE. So we have MPE here, and let us look at MPE. Yeah, MPE. So we need to read the documentation in forecasting principles and practice. So I think either
It's percentage, you were right, I've Googled it.
so I think it's mean
It's percentage,
mean
yes.
percentage, but without taking absolute value. I think mean absolute percentage error will be with absolute value in the denominator, and that one I guess will be without taking. I think like this, but it's better to look at the abbreviation, the acronym in forecasting principles and practice. It's mentioned there. So if something is unclear because documentation is still not, I think, perfect. Documentation is not perfect, but we go to look in forecasting principles and practice. Yeah, it should be about percentage, but mean this MAPE is also about percentage error. So I think this is without absolute value and that is with, but it's better to check the acronyms in forecasting principles and practice for acronyms like. So I use for sure root mean squared error, mean average error, and I think this one I know them. But okay, what else can we do? We can do model averaging. So what are the other tricks of this approach? We can do automatic variable transformation. We can do model averaging. Yeah. What we can do model averaging. Averaging. So let me create some. Once again, I have models. I will copy my code, and I will have seasonal naive. I will have. So let's have a seasonal naive. My ETS AAA, and let's have something like hybrid model. I think we can just say something like maybe in all the syntax, because I worked with Fable package while it was developing, and now the development is finished, and I'm still not. Sometimes the syntax. So in the beginning of it worked like that, but I don't remember for the moment. But let's check. Let's just multiply by sysnave plus 0.5 times ETS AAA. So I think that should work like that. No, so maybe it is like hybrid. Table. How do I aggregate models? Just a moment, maybe it's like that over 2. Maybe we need to first estimate them. So okay, let's estimate them first. Maybe we need to estimate them first, and then we add one more models. Models more equal to mutate models, and we add some hybrid model like 0.5 times seasonal naive plus, I think like that. So let's check ETSAA. With the same response variable, what's wrong? Mabel can name model with the same response variable. What's wrong? Just a moment. I will understand how to make hybrid forecasts. I like models. I just tried to create this model. I think we have the same. Model averaging. Just a moment. Okay, just 1 or 2 minutes. I will find a way to do it. Just a moment. Let me look at forecasting principles and practice, and we have a yeah, forecast combination, and we need to yeah, it's like this. Okay, let's check whether we need to add them and divide by 2, and that will work. Yeah, that works. Yeah, it's not, the syntax is a little bit special. It's not like 0.5 times, but it's the sum divided by 2. Okay, and now we make forecast and we evaluate all the forecasts. And we have where is our model? Models more. We are not so lucky, but sometimes, so it's not always the case. In our case, we are not lucky. Our hybrid model is in between models we have used. But maybe if I add something like ETS like this and like that. Hop, hop, hop. No, maybe I can combine with ETS automatic and divide by 3. Okay, I have not created a model that is better than every other models I have combined. Yeah, I was not lucky, but sometimes by combining one model with the other model, you can make a model that is better than both original models. So in this case, we are not so lucky, but sometimes the average of two models is better than each model. So it was not my case, because I've just took peer production at random. But do not forget about model averaging. That was not the case. I have not obtained better forecasts than with each model alone. Yeah, I have so that's a combination, but it's not better than the models I have combined. Yeah, it's better than ETS AAA, but it's like ETS AAA automatic or ETS AAA for logarithm of beer production. But sometimes try always averaging best models. That may give you a better result. Okay, what else can we do about
I'm sorry, but what is
Yeah,
the meaning of this hybrid model? Do we simply average the forecast values
yeah, we just average forecast values.
with the weights that we choose here, like divided by 2?
Here the weights are equal. Here the weights are equal. You may choose other weights. Just look at the forecasting principles and practice, and there are many more examples. So now weights are just equal. So now this is just forecast averaging with equal weights.
But there surely is the way not to equalize the weights. For instance, take 2/3 of ETS AAA and 1/3 of ETS Auto.
Yeah. Just look in the book. Yes, there are a way to do this.
Yeah, then, yeah, sure.
So yes,
Thanks.
but my idea is that normally the idea is to use models from different types. Maybe if I would use ARIMA and ETS, let's check. Let's check auto ARIMA, and so we will discuss ARIMA, I think, next week. But in general, the good idea is to average forecasts from models of different classes. So forecast from trigonometric BATS model, or average with forecasts with ETS, average with forecasts with profit model, and so on. So basically, it's a good idea to combine not models of one class, because here I have combined ETS from ETS, and it's better to try to combine models from various classes. I think neural networks plus ETS plus ARIMA, and that will be a good pretender. In my opinion, playing with weights is not so important that playing with different classes of models. So yes, you may choose weights, but it's better to have a model from completely different class type of model, and then to combine it, because basically why we're combining forecasts, we hope that forecast errors are not correlated when we speak about different models. And if we hope for that, then plain average will leave all forecasts unbiased, but will decrease variance, because when I take average, the variance of average decreases. Okay. Okay.
Yeah, sure. Everything clear.
What else can we do? We can do let's do some model selection, use model comparison using cross validation. Using cross validation. For example, you are interested in one step ahead forecasts. So imagine a situation you are interested in just one step ahead forecast. Your goal is to forecast next month's beer production. And when next month will arrive, you will be interested in, once again, in 1 month ahead forecast. Imagine you are interested in one step ahead forecast. Okay, you don't care about 2 years. Yeah, you are interested only in 1 month ahead forecast. In this case, probably it would not be a good idea to compare models using train test split. Yes, you still can use train test split. You can just split one last observation. Yeah, you can use one last observation as a test data set, but that will not be a good idea. Why? It will not be a good idea of just using last month as a test sample. Why split? Why using train test split comparison is not a good idea?
The split is
In this
useless.
case. Sorry?
We only need the last observation.
I don't get your question. We'd like to have, we are only interested in one step ahead forecast. So I would like to know the,
What I actually said is that this train test split is useless because the test split will contain only one last observation.
and why it's bad to contain one last observation. What's the problem?
That's not like representative sample.
Yeah, I agree with you. They may be just by chance that I have two competing models, model A and model B, and maybe just by chance on the last observation, model A outperformed model B, but by mere chance. So so the idea that error, mean absolute error, or any other error metrics will have a very high variance. Yeah, the problem is so it's question, it's answer. The problem is that the variance of forecasting metrics, the variance of or mean absolute error or other forecasting metrics will be big. So the good idea is to use cross validation. So we create one training split with one step ahead forecast. Then we either stretch or slide. So there are two possible strategies: slide or stretch. Many train plus one observation test split. So we will do train test splits, but not one train and test split. We will do many train test splits. The first one will contain, let's say, 50 observations in training set, 1 observation in test split. Then 51, or we will move it to the right. Let's say, let's move another 50 observations in training set. Once again, 1 observation in split set. So basically, we will do train and test splits, but not one split, but many train test splits. So there are 2 strategies, either to have, let's say, 50 observations in a train split every time and just move them up to the current time, or we may have just start with 50 observations training sample and just stretch it up to current information. Okay? Yeah? So now let's do this. First, we will create how it's so we will create a stretched or slided data set. So we will replicate our data set. Maybe it's a bad strategy, but that's a good strategy. There are some memory tricks. That's okay. No, that's okay. There are some memory tricks. I will not speak about them. I will work. I work with monthly and quarterly data. That's completely fine for high frequency data. You should be careful, but for monthly data, weekly, that's okay. And for high frequency, in any case, you should be careful. Okay, so I will create our production stretched data set that I will create stretch symbol. And what do I need? I need to specify my original house production. I need to specify initial length, let's say 10, and let's say specify the step will be, we will add 1 observation every time. Okay, let us look at our production stretched. So now it seems that we have, so let me look at the difference between our production and our production strengths stretched. So here we have 218 observations, and in stretched data set, it seems that we have 23,000 observations. Why it happened? So first we have a small, let's maybe, so we have 10 observations in training set and 1 observation in, so we have basically created all the training samples. So basically we create all the training samples. So we have 10 observations, then we have 11 observations, then we have 12 observations, and so on. Maybe it's a good idea to show you had house production stretched, and let's say 20. Yeah, you see, or maybe even 30. Yeah. 20, like this. So we see that we have a first training sample. So we have, this is the first training sample. It says ID, that means first training sample. It has 10 observations. They start from 1956 quarter one, and they go up to 1958 quarter two. Then we have second training sample. Second training sample starts from the same, sorry, second training sample starts from the same starting date, but it will have 11 observations. Okay, I have created a lot of training samples.
Clear.
Now the code is the same. We estimate models and we compare them. So now cross-validation may take a lot of time, so I will remove automatic model. I will leave only naive, ETS AAA, and ETS AAA for logarithm of house production stretched. So, because if I cross-validation takes some time, so it works for the moment. Yeah, I think we will wait a little bit. If you speak about automatic model selection, then it will even takes longer, because there are roughly 20 ETS models. And if you select cross-validation for 20 ETS models, then for every train split, you have 20 models to estimate for all training splits. And we roughly have we have almost 300 models, 300 training splits multiplied by 3 models. So basically we have roughly approximately 1,000 models to estimate now. So it will wait a little bit. Okay, so it finished. So for every training split, we have estimated 3 models. How many training splits we have? As our production has 218 observations, we started from length 10. So basically for each model, we have 208. So basically here we have roughly production. We have 2008 training splits, and basically 2008 times 3, we have 624 models estimated. Okay, we may look at them. There are a lot of models now. Yeah. So for each training split, we have estimated 3 models. Oh, even, sorry, even I forgot that I should add 1, yeah? 209. So we have a lot of estimated models, yeah? For each training training split, we have 3 models: naive, ETS AA, ETS AAA, but applied to not to original time series, but to time series after logarithm. Okay, now we may forecast. We can forecast just one step ahead forecast. Forecasts, we will forecast with all the models and our forecasting horizon is just 1 month. We are interested in 1 step ahead forecasts. Yeah, sorry.
I say, isn't our horizon in quarters?
Ah, yeah, our horizon is in quarters. Yeah, you are right. 1 quarter. But I think it's okay because it's minimal 1 step. So we can say even 1 when there are no doubts. 1, 1, 1, 1, 1, 1. Okay, because we have no problems. 1 is 1 unit. Unit is what? Okay, and now we can calculate accuracy. That's the same thing. We can calculate accuracy. What else? Accuracy. So we say forecasts, and we need to specify. What do we need to specify? I think we need to specify ounce production, maybe. Let's check. I'm not sure, but let's check. Yeah, okay. And now we now have forecasts. So we have evaluated our models using cross-validation. And it happens that with cross-validation, ETS is 1 step ahead forecasts of ETS AAA are a little bit better if I consider ETS AAA applied to logarithms. Okay. So this warning, we can safely ignore it. Why? It says that just we have also forecasted from the whole data set, we have forecasted 1 step ahead forecasts, and we have no real data for the last. So when we consider our whole data set, when the stretching training set attains the whole data we have available, and then we make the 1 step ahead forecast, we have no real data for the last for the future months, and it says the future data set is incomplete. So we have no real data for the future months, and it just ignores it. It adds non-available there. So that's warning we can safely ignore. Okay. Any questions?
No questions so far.
Then basically let's recap what we have done, what we have covered today. Today we have covered the modern data format for time series called Symbol, when we have time, data, and the key variable. Then we have covered how to transform character date into honest date object. Then we have covered some plots. Then what we have done, we have extracted autocorrelation function, partial autocorrelation function, KPSS unit root tests. We have considered naive models. Do not forget about naive models, even if you are building something modern. Then what else? We have evaluated ETS model. We have worked with ETS model on with paper and pencil last week, And now we have estimated it in R. What else? This is automatic ETS estimation. It uses Akaike information criterion to select the best model. When we have evaluated model accuracy using train test split, then we have done automatic variable transformation, because it's a good idea that just writing log here will not only take log, make forecasts, and then it will apply exponent function back. So it will do a honest comparison. You don't need to take log manually, to estimate model manually, and then calculate logarithm. You don't need to do it. This is done automatically. Pre-transformation and post-transformation are done automatically. You just write 3 symbols, log and 2 brackets, and pre-transformation and post-transformations are automatically done. Okay, pim, 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 pim. And we have done some model averaging, and we have compared models using cross-validation. Basically, that's all for today. I strongly advise you these 2 sources. So start from these. So these are slides, just slides, but sometimes slides is all you need. And this is a more comprehensive book. So I think these 2 sources are very good. So that's all for today. The next time we will have the last class of introduction to R and a little bit of time series modeling. And then after the next week, Diane Fantazzini will continue with more financial time series models. Okay? The question, if mean absolute error is lower for one model, and I don't understand the question. MAE is lower for one model, and MAE of the forecast is lower for another model. I don't understand. What is the question? Where mean absolute error is lower? Daria, it's your question. If mean absolute error is lower for one model and
so for example, when we solved, so we found that in ETSA logarithm, the MAE was the lowest, but when we conducted a forecast, now we see that ETSA MAE is lower. So does it mean that we should choose just AA and not logarithm AA?
It depends on it depends on what you are forecasting. So we have done 3 comparison. One is really bad but very fast, very rough in sample, using training sample. That one is a bad comparison, but it's very fast. It does not. We don't need to. This one is very bad. Yeah, we just we have no test split, and this is just comparison using. Sorry, we will have a lot of one. Oh, we will have 200 models because models now contain a lot. Okay, but never mind. So this is a bad comparison because it compares models using in sample. So it uses training sample. Okay, the second one we have used train test split. So if you are forecasting, let's say for 2 years, and you equally care about each of these forecasts. So you are required to forecast every quarter for next 2 years. And in this case, you do train test split and you compare, let's say, forecast for 2 years. And this is a better way, but it requires a little bit more time, but it's okay. And if you'd like to, if you have time to do cross-validation, but cross-validation takes much more time than just train test split. So the most, I think, precise evaluation of forecasting quality is using cross-validation, because you repeat train test split many times. But you may have, if you are estimating not 3 but 300s model, then cross-validation may be non-feasible, just a question of time. And so the answer to your question is, if you have time, then do cross-validation, because you will have lower variance for metrics like mean absolute error. If you have less time, just do train test split like this. And about courses on DataCamp, yeah, I will write. Okay.
Okay, thank you very much.
Okay, so bye-bye. Have a nice day, or sorry, evening. So
Thank
have a
you.
nice.
Goodbye.
Thank you, Professor.
Thank you.
Thank you for the lecture.
Thank you for the lecture. Bye.